Okay, so this afternoon we're going to do slopes and graphing lines in geometry. These are review questions from back in Algebra 1. This is a single worksheet for today. And then after that, we're going to start 3-3 on lines and slope, parallel and perpendicular lines. First thing we need to do to find the slope of a line is to count from left to right, 1 point to the next. I showed you slope guy the other day. Remember him? Should I draw him again? The point of slope guy was for you to kind of just in your head get in there that this is positive slope, this is negative slope, this is undefined because it's a vertical line, and that horizontal lines have a slope of 0. So for counting off the slope on this one, we should already know right away looking at it that its slope is downhill, so it should be negative. It's coming down and right. The change in the y I did in blue, the change in the x I did in pink, and that would be down 2, right, 1, 2, 3, 4, 5, 6, 7. Yep. So the slope of this line is negative 2/7, and we use an m to represent the value, the slope value. This one has a slope going uphill, so we should realize this is going to have a positive slope. To count from the leftmost point to the rightmost point that's shown in the dark dot, we would do this. Doesn't mean it's the only way to count the slope, but this one has a slope up 2 and right 1, 2, 3, 4. When you can reduce a fraction slope, you need to reduce it. 2 divided by 4 reduces 2/4 reduces to 1. Yeah, 1/2. Sorry? We're not writing the equation of the line yet. We will be, though. And that's when we'll need that y-intercept. Yes, ma'am. So the next one, to go from here, you should realize the slope is downhill. So you're going down. Looks like 3. And then right, 4. That's positive direction whenever you go right. Okay, so that'd be a slope of negative 3/4. Okay, I'm going to stop with the color and just do it. Left, right, up 1, 2, 3, 4, and right 1. So the slope is 4/1, which means m is 4. Now, this is different. And I think one of my problems might be different than your problems. Is number 6 not the same? Okay. I think you have... Okay, so I'll fix that right now. All right, now, what we're looking for is the slope of the line that's in the form y equals m times x plus b. That you should have seen before. M, a lot of kids have a misconception on slope, the slope number when it's written like this, and they put an x on it. I've seen that happen over and over the years. There's no x in the slope. It's the location of the slope in the equation. It's by the x. It's the coefficient of the x, is another the correct terminology. So all the slope number is the number in front of the x, called its coefficient. So this has a slope of 3/4. I'm not even discussing the b value right now. We don't even care about that at the moment, but I'll be discussing it when we go to graph a line. Oh, you're back. Hi. All right, what's the number here? Okay, 1. In front of the x term. When it's in this format, you can see the slope. Negative 3/2 for number 7 and positive 3/2 for number 8. Okay, next. Find the slope of a line. Wait, this is not... no, that's not the same thing. There you go. Okay. Find the slope of each line. Those questions I've moved to somewhere else. Okay. The slope of each line, this is not in the right format. We want it to look like y equals m times x plus b, where I got the x on the right side, the b on the, this stuff over here, and it starts with a y. How can I get this equation to start with a y? All right, let's get rid of the 9x. You've done this before in Algebra 1. So I bring down my y and my equal sign. And since I want to say mx plus b, I want the xy thing in the front. So I'm going to write negative 9x. That's a plus or a positive 4, so I write plus 4. I have to attach those. It's not wrong to write 4 minus 9x. It's just not in this format, and I want it in this format. So m is negative 9. I'm going to do an easier way to do this one. Instead of subtracting 2x, why don't we just add y to both sides? Doesn't that look easier? You can do what you did if you did it, but let me just show you why I did that. Because I can now do my symmetric property and just flip-flop it. Now it's quick, and you get 2. Did you get positive 2 anyway? Divide by the negative 1, yeah. It's not wrong to do it the other way. Just whatever. As long as you got a slope of 2, we're good. Okay, this one we'll need to subtract x. And then I see the number in front of x. There's nothing written there, so we think of it as a 1, and then it's negative. And this one, ooh, what's that? Well, how'd you know that? Good for you. 3 is right there. It's saying y is 3, and it stays 3, which is a horizontal line. All right, you can't miss this, please. Slope man, he's on the wall anywhere. What's the horizontal line slope? It's like his mouth. 0. Horizontal lines have a slope of 0. Vertical lines, undefined slope. So now we're going to try a couple more of these. We're going to get rid of the 4x. We got 5 times y equals negative 4x. So we're really not done on this one. We got to divide by 5. Which leaves me with y equals negative 4 x times x. And since there's something in front of x, that's my slope. Okay, I'll go ahead and do solving for y, subtract x, 2x. I'm going to bring down the minus y, put the negative 2x first. That's a positive, or no, it's not, it's negative 5, so I'll write minus 5. And then to clear up that negative sign in front of the y, we need to divide everything by negative 1, every term, or just change all the signs. Okay, and that gives us a slope of 2. It's the same as dividing by negative 1, which is the same as multiplying by negative 1. The result is all the signs changed. Okay. This one, subtract x. Negative 1. And the last one here, and then we're going to graph some lines. Writing the x part first, divide by negative 1. Don't forget to do or change everything's sign. So our slope is 7. Okay, let's graph some lines. Okay, the point I need to make. The number in front of x is your slope. The number at the end, the term right here, the B value. Do you remember what that's called? Yes, y-intercept. It is where you start the line. Okay, so on this line, I need to start at 1 on the y-axis. Okay, what's the y-axis? Well, it's up the vertical axis. And where you start, this right here would be your B value, or down here, anywhere on the y-axis. That's where the B goes. So, the 1 is on the y-axis right here. The slope of m is -4/5. Slope means to go down 4, right 5. So from that starting spot, you go down 1, 2, 3, 4, and right 1, 2, 3, 4, 5, and you make a point. This is really important that we can graph these. So I went from the starting point of 1 on the y-axis. I went down 4, right 5. You've done this before. So I'm going to reverse that now. What's opposite of down 4, right 5? Good. Up 1, 2, 3, 4. Left 1, 2, 3, 4, 5. And then just make a line through the 3 points that you got. All right, I see the slope is 1/2 here, which means to go up 1, right 1. Right 2, excuse me. Then I say, well, wait a minute, where's the y-intercept? All right, yep, it's 0. So that's where you start, is at the origin, 0, 0. Then you start moving your slope. And your slope was up 1, right 2. So you move up 1 and go right 2, make a dot, up 1, right 2, make a point. The reverse of that's down 1, left 2. Bless you. And you make a line. Thought somebody sneezed. Am I going too fast for anyone? No? Okay. Check her out. We got another y-intercept of 0. Graph that line. What does a -5 mean? You can stick a 1 under it. Slope of -1 would mean go down 5 and right 1. If you need to put that out in words, do it. Okay, graph those 2 lines. Should be kind of quick. And the opposite of down 5 right 1 would be up 5 left 1. So you should be done with number 27. '28, not much difference except it has a positive slope. Do not make me little stubby lines. Are we comfortable with these? Any questions? Anybody having any trouble, or don't feel like you can't ask me, because it doesn't mean you did well with this in Algebra 1. If you need more help, let me know. Okay, everybody got them going the right way? This is uphill, positive slope. This one was downhill, negative slope. Okay, if you've got this down, you can go ahead and graph the rest and just check them. Slope here is 1, 1 over 1, up 1, right 1. You can get lots of points on here for that one. Starting at 2. How many of you already did these? You're done. Okay, cool. I'll just go quick. You can check them. Do that right? Okay, I've got 31, 32. For you to verify you're doing it right. Like your folder color cover. Welcome. Nice box. Yeah, some good drawings in there. Okay. 3, y-intercepts. And the slope is down 1, 2, 3, right 5. Or up 1, 2, 3, left 5. Okay, fabulous. Hope that was a good warm-up for you. Now we're going to hit on some new concepts within the packet. All right, we're in the big packet. After this lesson, you should be able to successfully find a new slope to determine if lines are parallel or perpendicular. So we're just adding in one new concept. We've already looked at finding the slope between 2 points. You have this on your paper. You may remember that you want to know this formula. And that's for, of course, if you have a point x1, y1, and another point x2, y2. All right, now you always want to reduce your fractions, simplify, don't change them to decimals. Okay, so I've got an x1, y1, and an x2, y2. I'm going to be using the formula y2 minus y1 over x2 minus x1. That's your slope. So if I want to find the slope of this line, I'm going to take, and I'll do the coloring one time, or I'll do these on this page, but I don't think I'm going to keep doing it. If you find you need me to, or you need to, you go for it. I'm doing the y values in blue and the x values in pink. And then the process is to do the x's on the bottom and the y subtraction is on the top. Okay, so I'm trying to show you that you have to follow the formula correctly, else we got issues. Things will be upside down. Do not start with the x's. All right, so here we go. Got a division bar. I'm going to take 8 minus 0 and negative 2 minus 0, and you probably already said, well, geez, I could have done that in my head. So that's going to give me a slope of 8 over negative 2. You need to reduce that to negative 4. Second set, negative 5 minus negative 3, and the 3 minus negative 2. The next step would be to simplify the numerator and denominator. Negative 5, subtracting a negative changes to addition of the opposite. So it would be add the opposite of negative 3, which is positive 3. 3 minus negative 2, change to add the opposite, would be 3 plus 2. And you don't have to show this if you know how to do them in your head. That'd be negative 2 over 5. Third set, 3 minus negative 2 would be the first subtraction. y2 minus y1. x2 would be negative 6 minus x1 is 1. This becomes 3 plus 2 over negative 6 minus 1. You just evaluate. That's 5 over negative 7. I usually don't write the negative sign on the bottom. Negative 5/7. It wouldn't bother me, or I would not mark it wrong if you had it looking like this. It's just when you're graphing, I'd like you to apply the signs to the numerator. it's negative. Okay, now we're still doing some more slopes. Will you please try 4, 5, and 6 to see if you're going to do that correctly? I'm going to pause the recording. Okay, so it came back. I showed number 4. You should have gotten negative 1/2. For number 5, you should have 0 over 5. What do you get when you divide by 0? No, I'm not dividing by 0. I'm dividing 0 by something. 0 divided by 5 is simply 0. So that's an answer. That's an answer. Slope is 0. But what I believe this number has been changed to negative 4, correct? Okay, so this one, the x's are the negative 4s. The y's are the negative 3 minus 10. You got negative 4 minus negative 4. If those x's match, what's going to happen here? Negative 13 over, we get 0 on the bottom. You can't split up this class into nothing. What's that called then? Undefined. Or you can say no slope. It's why someone would fall off the mountain. Okay, there's a slope guy. No, that's a skier. Sorry, not slope man. All right, here we go. I'm going to do in different colors how we're climbing from line A to B. We're going to go from A to B. You want to start with A on the left, go up to B. And if the B would have been the one most on the left, I would have started with B. So you don't have to follow this letter order. So I'm going to go A to B. That's the movement. So I count it. How much did I go up? 1, 2, 3, 4, 5, 6, and right 2. So the slope is 6 over 2, which is 3. I should have stayed with the pink on there. Now I'm going to do a different color just because I want to show what I'm doing. Negative, I'm going to go C to D. C is the most left point, so I'm going to climb from C down and over. So that's going to be a negative slope. Down 1, 2, 3, 1, 2, 3, 4, and right 2. Down 4 and right 2 would give me negative 2 for the slope. Uh-oh, EM. There's not one more left than the other. I get to go 1, 2, 3, 4 up, but it can't go over at all. It goes over 0, and I can't divide by 0, so this is the line that is undefined slope or no slope. And that's because it's vertical. And finally, AE, go from A all the way over to E. I can go to the right, but I didn't go up or down. So that'd be a 0 on the top, 1, 2, 3, 4, 5, 6 on the bottom. When you divide 0 by 6, you get 0. That's the name of the number for the slope, 0. It has a value. Bottom of the page, we have to discuss how you can tell if lines are parallel and perpendicular, or perpendicular really. I almost want to say or because they can't be both parallel and, but it's about parallel and perpendicular lines. The slope of parallel lines, if they're running in the same direction, guys, what do you think the slopes are? They're going to be the same. They're slanting the same. Makes common sense. Okay, so the number in front of x will match if they're in the y equals mx plus b form. It's matched. That means you have lines that are parallel. The hard one for kids is the slope of perpendicular lines postulate. It says that if two non-vertical lines are perpendicular, it's if and only if the product of their slopes is -1. So here's this option. You take 1/4. Oh, let me change pens, please. All right, so 1/4 times -4 is -4 over 4 equals, which is -1. That's why these lines are perpendicular. There's another reason that you can use. You can also say their slopes multiplying to give you -1 is the same as the slopes being negative reciprocals of one another. Means I call them negative or opposite refliprocals. Flip. So example, what if you had 2/3? What would be the reciprocal? It also has to change sign. Negative means to change the sign. Yeah, so it'd be negative and flip it over. Those are an example of a pair of slopes that would provide lines that are perpendicular. And that means that they form right angles. The one's got to, if they're going to form right angles, does that make sense that one has to go uphill, one has to go downhill? Okay, one has to go uphill, one has to go downhill to make a right angle. So that's why their slopes are opposite in sign. Now, if I want a line parallel to this line, you guys got to change the page, so I'll wait a second. Parallel lines will have the same slope. This line has a slope of 1, so the slope of any line that's parallel to it would also have a slope of 1/2. Did I say something wrong? I think I said 1. This has a slope of 1/2. Any line parallel to that line would have the same slope of 1/2. This line has a slope that's -3/4. The answer will not be the same because we want a line that's any line perpendicular to it. So we need to flip and change sign. You got to remember, flip it and change the sign. So if I flip over -3/4, it will be 4/3. Now, 4/3. Shoot, I hit the wrong button. I'll just write it. Oh, it hates me when I do that. Okay. 4. Oh, I don't like writing like that. I'm just going to get a pen. I'm blowing it. All right, 4/3. Now, wait a minute. Did I change the sign? Yes, this was negative, so this one has to be positive. They have to be opposite in sign. All right, a line perpendicular to this has a slope of, this one's got a 5 slope. For this line, we need to say the line perpendicular would be, how do you flip over a 5? Put a 1 under it and flip it over. And change the sign. That one's positive, so this one has to be negative. So I'll get kids to remember, usually, that you got to flip it over, but then they'll forget to change the sign sometimes. And that's something we got to take care of. Remember, you got to do 2 things. All right, so we're going to determine now whether the slope of line A, B, and CD are parallel, perpendicular, or neither. Neither is going to be when if they're not equal, or if they're just numbers that aren't flipovers and opposites. Okay, so I'm going to take the point A and the point B. I did not need to rewrite that if you can just look over here. And then I'm going to find the slope. 5 minus -1 over 1 minus -1. That's 6 over 2, which is 3. Okay. I'm going to take the points C and D. I'm going to subtract the y's first, which is 4 minus 2, subtract over, the x is subtracted, 5 minus 1. That's 2 over 4, reduces to 1/2. Okay, if I got slope of one line is 1/2, and the slope of the other, oopsie, that one was 3. And the slope of the other line is 1/2, they're neither parallel nor perpendicular. Okay, that's when you say neither. Because it doesn't fit the definition for parallel or perpendicular. Try another pair. the slope of MN. How am I going to find it? I'm using these 2 points. I'm going to do 4 minus 0 over 2 minus 3. Oh, I did that backwards. I messed up. How did I do that? Messed up. I went too fast. So slow down. 4 minus 3, the y's, over 2 minus 0, the x's. That's 1/2 for the slope of line MN. Next, I'll find the slope of line RS. I'm going to say 4 minus 1 over 8 minus 2. That's 5 over 6. I can't subtract today, can I? 4 minus 1. I think I'm just getting tired. It's 7th hour. Holy moly. 4 minus 1, last I checked, was 3. And then you can reduce the 3/6 to 1/2. That's why it's so important to reduce, because now we see that both of these have the same slope. So the lines are parallel, and the reason is same slopes. Slopes are equal, whatever wording you use, that means the same, they have equal slope. So let's try 15. MN, going to find the slope, 5 minus 3, subtract those y's, 0 minus -1. Well, that's 2 over 1, which is just 2. Slope for line RS. Remember, this is a y2, y1. If you're still needing that, I don't care if you're labeling it, but I'm going to stop. The y's, -1 minus 1 would be on top. And on the bottom, 6 minus 2. That's -2 over 4, which is -1/2. Okay, the slopes are 2 and -1/2. 2 times -1/2 is equal to -1. That means they are lines that are perpendicular. The other way to look at it, you don't have to do the 2 times -1/2. You can say they're negative reciprocals. One's positive, one's negative, and they're reciprocals of one another. So these would be perpendicular because slopes are negative reciprocals. Or you could write for me, the product is -1. The product of slopes equals -1. I don't care which one. All right, see what else we got here. Let's do a couple of these graphs. It says, graph the line that satisfies each condition. Not every question is telling you it in y = mx + b form. This says, have a slope of 4 and pass through the point 6,2. So we want to plot the point 6,2. Okay, if the slope is 4, 4 over 1 means up 4, right 1. So from the point they gave us, we go up 1, 2, 3, 4, and right 1. Do it again. The reverse of that would be down 4, left 1. And then make a line. Now you're using the same grid for both these questions, right? So this is a separate line for number 17. So I'm going to do it a different color. It says passes through the point 8,5. So I'm going to go find 8,5 and make it point there. And I'm going to label it H because it called it H. It says we want to go and make a line through this point that is perpendicular to line AG with a slope of 1/2. Perpendicular lines, it wouldn't have a 1/2 slope. It would have a slope then of -2. I took 1/2, I it over and change the sign. So if it goes through 8, 5 with a slope of -2, it's going to have to come down 2, right 1. Or up 2 from there and left 1. So this is all they're telling me. They did not say it was going to be perpendicular to this line that we already have here. They said it would be perpendicular to some line called AG, who had a slope of 1/2. I don't know where AG is. That's all it's asking us to do. Graph the line. Anybody still need this page? Pardon me? I know, it's kind of confusing that there's no line AG on there. You get what I'm saying? That would be nice if it was there so you could kind of see it hit the other one. So this one's kind of like that too. Point, we're going to plot this point. -1, 5. I'll put a C on it. Parallel to some line called AB, LB, whose slope is the 4th. I don't know where LB is. I could make one up, but they didn't give me one. But if it's parallel, it's going to have a slope of 1/4. So I want the slope to be 1/4 of the line hitting C. I got to make another point, though, so I can graph it. So I have to go up 1, right 4. Up 1, right, 1, 2, 3, 4. And then I could go down 1, left 4. All right, this is the line they're referring to. Somewhere there was a line LB who happened to be parallel to it. That's all. This hint is here is just telling you what slope to use. Okay, one more example here. A plane. Ooh, a plane. Okay, that looks like not a plane. It looks like, I don't know what that is, a blob. All right, so you got a plane flying in the air, and he has to come down. And he's coming down at a rate of 300 feet. Oh, down 300 feet. He didn't plummet, no. He's doing that over a period of 5,000, okay? So it's like the plane's coming down like this. Its rate of change is 300 feet for every 5,000 horizontally. So what's the slope of this thing? Oh, we're going down, aren't we? And -300 over 5,000. The horizontal number goes on the bottom. So we can cross out some of these zeros. So it's coming down -350. -3/50. No. Don't need a label on that one. And you know what's next. Whew. Have a great evening.